Welcome to Mimi's Math channel. Today I will discuss incenter and circumcenter. So let's go over the definitions first. Incenter is the point of concurrency of the three angle bisectors of a triangle, whereas circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. So the way that you could possibly remember this is think of the letter I and the letter A. They're both vowels. So you can either do that or you can come up with some type of mnemonic device, maybe I ate bananas. I don't know, something like that. And then if you look at circumcenter, C and P are consonants. Or again, you can come up with something to help you remember it, like chocolate and peanut butter. That helps me. So those are just some ideas. And then you have to also know how to identify what they look like. So as I mentioned, an incenter is going to be created by angle bisectors intersecting or a point of concurrency. So my angle bisectors look like this. And right in the middle, that is called my incenter. So what I need to know about the incenter is that it is equidistant from the sides of the triangle. That's why you see in red these perpendicular lengths here. So if I were to actually draw in my circle, and bear with me while I attempt to do this, it's going to be inscribed inside of my triangle. So what you will notice is when my inscribed circle is drawn in, the end radius are going to be the same. And that's notated by those perpendicular lines there. So they're all going to be the same length, and they're equidistant from the sides. So now what we want to do is look at part A. And part A is giving me information. It says, given that PW is 2, so that's one of my end radii, and UX is 3.46, so that's part of the triangle side. Find UP. So I'm trying to find this blue angle bisector right here. What I need to remember is, like I said, the radii are going to be the same. So if I look at this portion over here, I see a right triangle, and I also see that that part is going to be 2. So all I have to do now is set up my Pythagorean theorem. And in doing that, I'm going to use Pythagorean theorem, which is a squared plus b squared is equal to c squared. And it doesn't matter if I use the 2 or the 3.46 as the a and the b, they're interchangeable. What does matter is my hypotenuse is directly across from my right angle symbol. So I know that has to be my c. That's what I'm looking for. So I'm going to go ahead and substitute in. I have 2 squared plus 3.46 squared, and that's set equal to c squared. And what I want to do is I want to go ahead and simplify that on the left-hand side, and I see that I have 4, 2 squared is 4, plus 3.46 squared is 11.9716. And I'm trying to get rid of the square, so the inverse is to take the square root. That gets rid of that, and it leaves me with C, and I'm just going to flip it. C, once I simplify the square root of that sum, is going to be rounded to 4. Well, C represents UP. So the length of UP is actually 4. Okay, so that's how that works. Now, part B works with the angles. Given that the measure of angle XUP is 27, so that's this portion here, 27 degrees. And I see I have an angle bisector. So this part of my angle as well as this part are going to be congruent. So together, 27 plus another 27, this total angle is going to be 54 degrees. And the measure of angle WTY is going to be 62 degrees. So that's this entire angle, 62 degrees. I'm asked to find the measure of angle PSW. So that's this one. Trying to find that. What I know is that a triangle equals 180 degrees if I add all 3 of my angles together. So out of that 180, I know 54 and I know 62. So I want to add those together. And so that's going to be 180 minus 116. And that's going to give me the measure of angle XSW. So, and that's going to end up being 64. However, that's not what I'm looking for. I'm looking for a portion of that. So I want the measure of angle PSW. So I would just have to divide this by 2. and that's going to tell me that it's 32 degrees. So each one of these angles, which are bisected means it's going to be cut into two equal parts or two equal angles in this case, will give me a total of 64 degrees. And if I added all three of those angles together, it will give me that 180. Now for example 2, this is an example of circumcenter. Circumcenter is equidistant from the vertices of the triangle, and it's created from perpendicular bisectors. And you can see that the bisectors have the 90-degree angles here towards the side, and right in the center, that is called the circumcenter. And as I was saying, in terms of equidistance from the vertices, each one of these, if I had an angle bisector, would be equidistance, because as you just saw, I hand drew this so it might not be as accurate, but if you look at it, that's a radii in each direction, or in radius. And so you also need to notice that you have a circumcircle, or it's also known as a circumscribed circle, which actually is connected with the vertices of the triangle, whereas the other one was inscribed on the inside. Okay, so now let's just follow the instructions to complete example 2. Given that DF is 50, so that means this entire side of the triangle is 50, and EH is 18, that's already shown for us. Find DK and EF. Well, DK, if I look at the side of my triangles, I see that it's a perpendicular bisector, which means it's cutting it into two equal parts. So if the entire thing is 50, I just divide it by 2. So DK will be 25. And EF is this entire length of the triangle, but I know a portion of it is 18. And if I look at my tick marks, I see that both EH and FH, or HF, are both 18. So 18 plus 18 is going to be 36. So EF is 36. So those are the main things that you need to know about incenter and circumcenter. Thumbs up, subscribe, have an awesome day.
Subscribe.